Hi everyone, in today's lesson we're going to talk about limits with conjugates and common denominators. So yesterday we talked about the limit flow chart. We said we're going to try direct substitution, and if we get any real number, we are done, and that is our answer. And if we got 0 over 0, that meant there was a hole. And yesterday we only talked about factoring our way out of the hole, but there's two more ways that we can get out of holes using something called conjugates and common denominators. And just like we did yesterday, we're going to then substitute into our simplified expression after we've done one of these algebraic techniques, and then you're done and that's your final answer. All right, before we get into limits, let's talk about conjugate pairs and how they multiply out. So a conjugate pair consists of two binomials with identical terms and an opposite operation between those terms. So example, x plus 5 and x minus 5. Those are conjugates. Same x, same 5, just the plus and the minus. Even radicals, radical x plus 2, radical x minus 2. Same first term, same last term, opposite sign in the middle. Same thing here even. X minus 3 is the first term, and the plus 1 and the minus 1 switch, positive, negative. The stuff under the radical is not switching. That's part of that same first term. So let's see how these multiply out together. So you're familiar with x plus 5, x minus 5. If you were to double distribute, just follow along with me here quickly. I assume everybody can do this. This is what would happen when we double distribute. And we'd have to combine like terms. What you're going to notice is that these middle terms are going to cancel. So we're really left with x squared minus 25. Now, will that happen, that these middle terms cancel when you have radical expressions? Let's find out. So here we're going to multiply radical x times radical x. So when you multiply a radical by itself, I want to show you what's happening. You're doing rad x times rad x. You can multiply insides with insides and make this the square root of x squared, which will simplify to x. Or you can understand that multiplying something by itself, rad x times rad x, is the same thing as squaring. And you should remember from pre-calc that a square and a square root cancel each other out, so that value becomes x. So knowing that when you multiply a radical by itself or square it, it just really turns out to that thing inside. So radical x times radical x is just x. Now, rad x times negative 2 is negative 2 rad x. Now, 2 times rad x is positive 2 rad x. And 2 times negative 2 is negative 4. So look what happens here. These middle terms are going to cancel again. Perfect. So it's nice and simple. This reduces to x minus 4. So same thing over here. We're going to double distribute, but we have rad x minus 4 times rad x minus 4. Now, it's not as simple to multiply these the way we did x times x to give me x squared. We'd have to double distribute all this stuff, and it's really just not necessary. We can use the fact that we know that it's x minus 4 squared. The square and the square root cancel each other out, and we're really left with x minus 4. So that makes that multiplying much easier. And then we have this times this is negative 3 rad x minus 4. This one times this one, positive 3 times x minus 4. And 3 times negative 3 is negative 9. And you should notice also that these middle terms are opposite signs, so they cancel out as well. So you're left with x minus 4 minus 9, which is x minus 13 if you combine those like terms. So what I wanted you to get from seeing this is that no matter what, as long as you're multiplying a conjugate pair, the middle terms will cancel. So if you know that, you don't even have to multiply the middle terms. All you really have to multiply together to get the x squared was the first and the first, and the last and the last. So all we have to do, let's see if it works over here. First times first was this, last times last was that. Same thing over here. First times first gave us this, last times last gave us this. So in order to get a simplified answer with multiplying conjugates, all you have to do, you can put a little star here, is multiply firsts and lasts only. And again, this only works if you have a conjugate pair. If you don't have a conjugate pair, you can't take that little break. Okay, so here we go. Let's apply this stuff now. So what we need to do here is evaluate a limit using conjugates. So when we evaluate limits algebraically, we are always, always, always doing direct substitution first. That's never going to change. So everywhere we see an x, we're going to plug in positive 1. So we're going to plug in 1 minus 1, square root, 1 plus 3 minus 2. So we know 1 minus 1 is 0. We know the square root of 4 is 2. 2 minus 2 is also 0. So we have 0 over 0. That must mean we have a whole and an indeterminate form. So we now have to use one of the techniques. We obviously can't factor like we did yesterday, but I have radicals. So we're going to use conjugates to simplify. So let's rewrite the expression. You will need it. So x minus 1 over rad x plus 3 minus 2. So the best way to do this is to multiply top and bottom by the conjugate of wherever the radical is. In this case, the radical is in the bottom. So we are going to write the conjugate, and we're going to multiply it. Remember, conjugate means to just switch the middle term. Everything else stays. So I switched from negative 2 to positive 2. Now over here, we're going to multiply the same. Whatever I do to the bottom, I have to do to the top. Okay? And then we're going to simplify this. Now, a pro tip here is that you only need to multiply out the conjugate pair. You want to leave the other piece alone. So in this case, this is not the conjugate pair, this x minus 1 times this. So you're going to leave that, and you're only going to multiply this bottom piece together. But like we just found out in the last example, when you're multiplying conjugates, you only have to do firsts and lasts. So we're going to multiply this radical times this radical, and you know that it becomes itself. And then this one times this one. Those are my lasts, negative 4. And then that can reduce to x minus 1. Now, the reason why you don't touch the other part is for this. If I were to write it out now, we have an x minus 1, rad x plus 3 plus 2. I'm just going to rewrite it again, x minus 1. You should probably put that in parentheses, times rad x plus 3 plus 2. By not touching the top, you should realize that this x minus 1 will cancel with that x minus 1. And that's always going to happen if you follow the advice of only multiplying the conjugate pair and not the other. So let's go on from here now. Step 3 is try direct substitution again. So we're going to plug it into the expression that's left, x plus 3 in the radical plus 2. So I'm plugging in x equals 1. So radical 1 plus 3 plus 2. We see this as the square root of 4 plus 2. So 2 plus 2, final answer here is 4. Okay, so the last example requires us to use another strategy called common denominators. So let's take a look. Step 1, as always, is our direct substitution. So I noticed that there's a little typo here. This is supposed to be as x approaches 0, so feel free to change that. So let's do direct substitution. So we've got 0 for x, 1 over 0 plus 2 minus a half. Obviously, the numerator stays 0. Here, 0 plus 2 is 2, so this is 1/2 minus 1/2, which again is 0. Here is my indeterminate form, or my whole. So now in this case, we can't factor, and we can't use conjugates because there's no radicals. But since there are fractions, we can use common denominators. So what I'm going to do is just rewrite the expression so I have something to work with. And then we'll talk about how we can do that. So x, it would be in your best interest to exaggerate this division line. I'm going to use a different color for all pieces. 1 over x plus 2 minus 1/2. So obviously the x on the top doesn't need to be simplified, so we can leave that as x. But on the bottom, we need to make a common denominator. Now, when you can't find something that you can multiply 2 by to get x plus 2 or vice versa, you simply multiply them by each other. So this needs to be multiplied by x plus 2. Whatever I do to the bottom, I do to the top. This one needs to be multiplied by 2. So I have 2 over 2 times x plus 2. All I did there was do 2 times 1, which is 2. 2 times x plus 2, I just left it. Then I'm going to subtract x plus 2 over 2 times x plus 2. Again, all I did was 1 times x plus 2 is x plus 2. 2 times this is that. So let's keep going. Let's put our equal sign. And my x on top stays. So in order to subtract these fractions, our denominator needs to be the same, which it is. So 2 times x plus 2 is our common denominator. And then we just subtract the tops. So it's 2 minus x minus 2. Don't forget to distribute that negative that's there. So feel free to, if you need to, put this in parentheses so you know that it's negative x minus 2. So it's 2 minus x minus 2. You should know that these 2's cancel, right? 2 minus 2 is 0. So we're left with negative x. So now, in order to simplify a fraction like this, you want to use the division rule for fractions. You want to keep, you want to change, and you want to flip. Now, the keep part is x. You're going to keep it, but you're going to write it as a fraction, x over 1. Any number can be written as a fraction if you put it over 1. So we have keep, we have change, and we have flip. So we're going to flip the last fraction and cancel some things out. Well, I see these x's can cancel, which is great. And this is really saying 2 divided by negative 1. So you can go ahead and put the negative with the 2. So negative 2x plus 2. That, my friends, is your simplified equation, which leads us to step 3, is to do direct substitution again. But now this time we're going to do it into this equation. So we're going to substitute directly with 0 again, and that's our final answer. So negative 2, 0 plus 2. We know 0 plus 2 is 2, so negative 2 times 2 is negative 4. Final answer. All right, I know that was a lot for today, so if you have any questions, now's a good time to jot them down. Otherwise, we'll see you tomorrow in class. Have a good night.